Exchanging Ideas Global 5G Evolution, covering the best speakers from worldwide.
Kanishwaran Govindasamy from Kuala Lumpur, Malaysia.
Professor 𝗏𝗏 from London, UK. Muhammad Fazil Salimi from Tokyo, Japan. 𝗘𝗃_адц from Singapore. Professor 𝗦𝗂𝗽𝗽_cie𝗍𝗂𝘁 from Rabat, Morocco. Axin Kotwani from Ivory Coast. Sadiq Malik from Paris, France.
Hassan Hossein from Porto, Portugal. Join the conversation on the 22nd of April 2020 on LinkedIn.
Thank you, everyone. I would like to introduce Mr. Hassan Clausen. He's the CEO of Hanscom Media, the founder of 5gbrief.com summit. And yes, Mr. Hassan, please.
Yeah, okay. Yeah, good morning, everybody. And yes, good morning, Kanish, for inviting me and for setting up such a kind of virtual panel of experts. I mean, during the Corona lockdown, we need to have alternative formats to, to get together, to stay connected, and to exchange ideas and to do such brainstorming. So I really appreciate your initiative. Yes, you said this. We are organized, just to introduce myself for a moment, we are a conference organizer in the telecom industry, and we have one series, which is the 5G briefing, where we are gathering all the experts together with 3GPP and 𝗬𝗏𝗍 and all these organizations, international speakers and so forth. So we did this in Istanbul, in Paris, and Frankfurt, and we have now another one even planned, or we had one planned in May, and Kanish was one of our distinguished speakers and panelists at the conference, but we had to postpone and we had to reschedule it. And so in the meantime, good to see guys like Kanish to organize other formats and other events that we don't lose tracks. Okay, just short about the 5G. I mean, I believe in general there are basically three important areas that should be covered, and I'm sure that all of you can contribute to them. One of them, the first maybe, is business environment. I mean, when we're talking about 5G and business environment, we're facing today a successful 4G LTE established market. So what is the benefit to introduce 5G, and how can operators create revenue, and how they can convince the user to switch to 5G or to use 5G? So the business environment is definitely something that is very important to take into consideration and to think about. Another one I would say is the 5G deployment. There will be more spectrum needed, and but when will it be needed, and which bands are needed, and what are the costs for it? I mean, we see all the auctions in several countries. We had the experience in Germany where they paid billions for the 4G and LTE band. So there's something that needs to be also to take care into consideration about the 5G deployment. Another and very important point I would say is the vertical industry. I mean, 5G is not just that my daughter can download the streams of her videos faster than before. I think the 𝗀𝗏𝗏𝗏𝗏 is something that is important in the vertical industry when we talk about automotive, transportation, healthcare, utilities, smart cities. What comes first, and what is the most promising thing? I mean, everybody's reading about autonomous driving. Talking again about my daughter, she said she doesn't want to drive a car. She wants to sit there playing with her mobile device while the car is driving alone somewhere. So this is something that the low latency is important in much industry. So this is something the vertical industry, I would say, is a very important part of plans in 5G. Because 5G is not just about high speed only. There will be more capacity with access to new spectrum. There is mission critical communication, as I mentioned. There's the healthcare, there's the automotive, there's virtual reality, augmented reality, IoT. There are many areas where we believe that 5G will play an important role. And I think these are the three areas, maybe business environment, 5G deployment, vertical industry, that are maybe the key of success of 5G in the future. And I would be very happy to find out what you are planning, what you are thinking about. This group of experts is going to discuss certainly these points. And I would say including security, monetization is something that I would like to hear your opinion. And once again, I'm very happy that that Ganesh managed to get these experts together to discuss these parts in this virtual environment. And as I mentioned at the beginning, we are planning to have our face-to-face meeting, the 5gbriefing.com. If you like to have a look at the website, and if you like to join us in the next events, which are going to be in Frankfurt, the next one in Madrid probably. So yes, happy to hear you. And I'm really not that big expert in these things. I think I have a basic overview about it, but I would like to invite you guys to give us more detailed information about what you think about. And yeah, thanks for having me here, and I'm looking forward to stay in touch with you and to hear your next comments.
Great. Thank you, Mr. Hassan. Thank you for your time.
Welcome.
So the next speaker, I would like to invite 𝗂𝘂𝗽𝗽𝐺𝗿𝗂𝘂 Salimi from Tokyo, Japan, to discuss on the 5G core radio onboarding over cloud platform.
The microphone.
Your microphone.
Yeah. That's fine.
Yeah.
Okay. Thank you very much. Okay. Hello all. I'm 𝗂𝘂𝗽𝗽𝐺𝗿𝗂𝘂, and nice to meet you, all of you experts and professors here. It was my pleasure to have time to discuss, but as we are limited to just 10 minutes, let me start to fastly present my presentation. And yeah. Okay, today it is planned to discuss about cloud platform, 5G implementation over cloud platform. And as most of you know, there was a differences between CT and IT era. CT just was looking for the packet forwarding, so huge number and huge space consuming servers will be provided by telco vendors, but now we can see that most of them are migrating to the IT. So we want to know what is the history and how to go to cloud platform. Okay, my assumption is that today we will find that what is the financial benefit for cloud platform for the telco operators and vendors, what is the fast delivery and time to market over this cloud platform, and the technical aspects, how to do that of these cases. Okay, let me just start about the telecom implementation history. As a rapidly definition, you know, the first era was that a telco vendor provided customized big hardware, OS and software by themselves and provide the service on top of that. So it was power and space consuming for us. It was a headache for IT man to operate, to maintain and develop service on this kind of the hardware. So rapidly we changed the era to the next one in order to use virtualization. So in this case, we could just use COTS hardware, commercially on the shelf hardware. It was too much cheaper than the custom hardware from the vendors. So using hypervisor, we could install our VM with the guest OS and provide the service on top of that. So vendor just need to provide service and related framework. After that, container came to market to provide easier way for serving the customers. It was more faster than VM. I will go through that one. And at the end, we can see cloud native era. In this era, cloud native mix container-based platforms and also microservice architecture that we want to discuss. Okay. Okay, as a simply comparison between VM and container, as far as you know, for the VM-based solutions, you just provide the hardware, you put your hypervisor on top of that. Hypervisor included host OS, and also hypervisor was responsible for cloudification and virtualization. So on top of the hypervisor, you could provide your VM, and each VM need dedicated guest OS to run the application on top of that. But why we say container is more easier and faster to provide the service? Because in the container, you just provide host OS on top of the hardware and use Docker or container engine in order to share the host OS kernel and provide isolated spaces. We call it container. And just this, you can put your app on each container. It will work separately from other containers. So it was a decision of Cloud Native Computing Foundation to use container-based instead of VM-based services. Okay, let's have a review about the microservice architecture. You know, as a legacy software architecture, we had monolithic or monolith architecture. In this one, service includes some kind of module that they are dependent and connected together. So in order to run the service, all of them should run. So if one of this module come down, so service come down as well. And so in another hand, newly we have microservice architecture, which means that service will be divided to some individual and independent microservices. Each microservice includes some independent modules. So you have your separated developer. Each developer can work on each microservice in parallel, so you can develop your whole service sooner than before. And also, if you have any problem for each microservice, you can do the troubleshoot without affecting any other microservices. So it was the next decision of Cloud Native Foundation to use microservice architecture. Okay, I want to discuss about how to implement 5G over container and also microservices. So I want to have a fast review about the container concepts. As I mentioned, Docker is responsible for building the container. Shipping the container means that to packaging all the service codes and related dependencies and put it in the registry, and also run the container in any host. It can be bare metal solution, which means dedicated hardware, or it can be nested solution, which means you will use VM as the host or node of this container. But the case is that, you know, some kind of application, same as MME in 4G or AMF in 5G, they need many containers to serve their current services. So Docker is not somehow powerful to manage and automate all the container together. So we need a centralized environment to automate the development, deployment, and maintenance of container. The most popular solution is the Kubernetes. Okay, what we do in Kubernetes, we provide and define pods, and each pod is responsible for a specific service. Each pod include one or more than one container, so all of these containers has the same goal and they share their resources same as database. And also we define Kubernetes cluster, means that all the pods in this cluster should communicate together, and some of the pods should be the edge of this cluster to work with other clusters. For example, you can have a separated cluster for your radio, and you can have a separated cluster for your core network. This is the nature of Kubernetes. Okay, let's go. Let's onboard 5G over the container. And as an example, I provide 3 network functions, AMF, SMF, UPF, as dedicated pods. You know, we will have a set of pods for AMF, dependently for SMF, and also for UPF. Okay, what happens if one AMF pod comes down? We will have another pod that act as AMF. So service would work. It is very good. It is fancy. But what is the case? You know, AMF is a big amount of resource. It consumes a big amount of resource. So why not we use microservice on top of this container aspect? I mean that let's divide AMF to the microservices. For example, for NGAP protocol to discuss with radio, for HTTP to discuss with other SPI interfaces, and nodes, and mobility management service and session management service. We will have different and separated pods for each of them. In this case, the maintenance, deployment, development will be too much easier. Assume that one mobility management pod comes down. So we have another mobility management pod that work and there is no any effect. Also, this is just one pod that consumes few number of resources. So you lose few amount of the things, not whole AMF. It is very good. And also, if you want to develop one of your services pod by pod, for example, you want to develop something, change something in NGAP proxy, so you don't need to touch other pods and also other services. You know, there is no any effect on the other services. And also related to the utilization. Before, if you wanted to scale one, for example, AMF or MME, you should build another MME that's consuming many resources. But in this case, you will find that, okay, my HTTP proxy is going to be utilized. So what I should do, I should just add one other pod as the HTTP proxy. So yeah, this is what we call it 5G in cloud native. But the case is that how to handle the traffic between this huge amount of pods. Which pod is responsible to send to traffic to which pod? This is service mesh aspect that help us beside the Kubernetes. You know, service mesh inject sidecar container, we call it envoy. It is service mesh proxy to each pod. So means that all the traffic will be carried by this envoy sidecar. So envoy is aware about all the traffics. This is just user plane part of service mesh. So we should have another part as control plane to control all of these proxies, envoy sidecars, to provide the rule how to traffic should be distributed. For example, it is load balance or some kind of deployment, canary updating deployment, dark launches, how it will be done. And also some kind of metrics will be passed to this control plane for observability and other aspects. And also this control plane provide the security aspect. So, okay, one of more important telco industry requirement is observability. And thanks to CNCF and also open source softwares, in the right side of service mesh ecosystem, we can see Prometheus that is connected to the mixer, one of control plane module of Istio service mesh. All the metrics and KPIs will be fetched by Prometheus, and by using Grafana, we can have a fancy KPI management and KPI monitoring dashboard. On another hand, we have tracing aspect. Thanks to Jaeger, we can inject Jaeger client and Jaeger proxy to each pod and each envoy module. So envoy module provide all the tracing data to Jaeger database, and Jaeger database can provide unique centralized tracing dashboard and software for us. That is very good. So just we need to come into somehow as a visualize flow. So what is this? This is 𝗂𝗽𝗽 exactly. 𝗂𝗽𝗽 will fetch all the tracing aspects from Jaeger and provide the tracing flow for us. It can be somehow used as, for example, instead of vendor-specific tracing tools. Okay, most of the things are covered. Just two other aspects are remain for one telco operator to provide 5G over a cloud platform. The first one is logging and log management. As far as we check, most of the vendors, core vendors or radio vendors, they use 𝗬𝗪𝐾 stack and Elasticsearch for log management. So the best solution is Kibana on top of this 𝗬𝗪𝐾 stack to provide the logging dashboard and some kind of alarming for us. Okay, the most important thing for operation is configuration management. You know, most of telco vendor provide a unique centralized configuration management tools and environment to somehow convince us to buy many things, all the I can say network function from one vendor to use just same configuration management. But now we have CMOS configuration management as a service, so it just will be integrated to the O&M interface of each network function through using the APIs. It can be RESTful APIs. If we are the owner of cloud platform, we can deploy CMOS by ourselves, or if we are using some kind of vendor for the cloud platform, we should ask cloud vendor to provide CMOS, and we should check if they could support both GUI and CLI for CMOS. Okay, it was all. Thank you so much for attending and listening to this session.
Thank you, Mohammad Fazil. Now, I would like to welcome Professor Abdelali from Rabat, Morocco.
So, the agenda for today, I will start just by a brief curriculum vitae of mine. I will also introduce my talk by talking about some few concepts in 5G. I will also talk about spectrum, use it or share it. I will present some standardization activities towards spectrum sharing in mobile networks. Basically, a brief overview of Release 16, which introduces the 5G new radio and licensed. And I will conclude my presentation by some final remarks. Okay, so I'm an assistant professor and a 5G consultant since 2015. Before that, I worked as a voice over IP consultant architect at Alcatel-Lucent for roughly 8 years. My research interests are mainly related to spectrum sharing for 5G and 5G networks. And before that, I worked also on some concepts in cooperative communications in wireless, mobile, and vehicular networks, cognitive radio, multimedia content delivery. I'm also involved in some research projects, some national research projects on smart grids. So just to start my talk, I need to recall some basics. So the mobile market has evolved from the first generation to the fifth generations. How? So the first generation was the generation of voice-only applications. So we have only voice. But later, this has evolved to text, internet access, and 4G was the generation of mainly rich video. And now in 5G, we don't talk anymore on a device, but we talk on a connected object. So there is cars, there is industry, IoT. So we talk about a connected environment, and so there is many customer desires to accommodate. So the notion of service in 5G, it's the basic evolution. We talk about video in 4G. Now in 5G, we talk about three scenarios. We talk about EMBB, we talk 𝗬𝗪C, we talk also 𝗬𝗵TC. In 6G, we will talk about new combinations of requirements for new use cases. According, for example, to entity document white paper, we will refine those services. As today in research works, we see that the three application scenarios are not anymore sufficient. We need to refine and we need to introduce more specific use cases. So we need more services. This comes at the expense of more need in terms of throughput and in terms of capacity. So capacity now is a serious bottleneck for telecommunication operators. We need to achieve gigabit and terabit, so gigabit speeds for 5G and terabit throughputs for 6G. So this is not easy to achieve. For example, let's talk a few about some mathematics. The capacity, which is in terms of bits per second per kilometer square, is cell density times spectral efficiency times available spectrum. Okay, so to increase capacity, we need basically to increase some or all of these metrics. Basically, if we need to achieve, for example, 100 or 1000 times speeds, we need to increase each metric by 10 at least. Okay, but this is not easy. We need, for example, to densify the network. We need to deploy more cells. This is very expensive, and we have also the interference issues. Okay, because we will get to more dense network. To increase spectral efficiency, we need, for example, to increase spectral efficiency. It's very hard to increase. It's very expensive. To increase spectral efficiency by 2, we need to increase power by basically 20 times. Okay, so, a practical way to do it is to deploy massive MIMO. Okay. Finally, to increase capacity, we can also simply increase available spectrum. Okay, so one practical solution to have more capacity and more throughput today is to have more spectrum. There is 2 ways to do it. To have more spectrum, there is 2 ways, 2 popular ways. Either to introduce new bands. So there is, we are talking today about millimeter waves, terahertz waves also. Another way to do it is to allocate additional spectrum through either sharing or refarming or getting access to unassisted bands, for example. Okay. There is a dilemma in research papers that treats the subjects of spectrum management and spectrum availability issues, which is spectrum scarcity versus underutilization. Okay, why? Because radio spectrum today is exclusively and statically allocated to various technologies. Spectrum is cumbersome today. Okay, however, if we get more deep in the utilization metrics or measurements of each frequency band, we will see that the utilization of those bands is very sporadic. Those bands are sporadically utilized. For example, if we see the statistics of military and TV events, it is very sporadically utilized. So this perceived spectrum shortage is rather a problem of spectrum management policy than physical scarcity. Okay. There is also the issue of lower bands. We need to achieve high coverage or longer coverage. We need to get access to lower bands. But